Evening, sir.
Good evening, sir.
Good evening, sir.
Good evening.
Or-
Good evening, sir.
Yes. So in the last session, we have discussed some foundations of networking, right? The OSI model, TCP, UDP differences, and TCP IP model, right? Today, we are discussing about this still basics only, IP address subnet mask. And after that, we're moving on towards the CIDR, the advanced networking concept.
Recording in
Download
progress.
from internet. And these small software applications, it will allow you to configure IP address on your machine. Okay. So it's not always that you need operating system software to configure IP address. These days, there are lots of developers who developed small applications which allow you to configure IP address directly on your machine. But whether you are using your operating system software or you are using third-party applications to configure IP address on your machine, you are using software. That is the main thing. You are using some software to configure IP address. That is why this IP address, it is also called as software address. It is called as a software address of your machine. We also call it a logical address. Now, why logical? Because this address, you can change it at any given point of time. Suppose you are using one IP address right now on your machine, and maybe you want to change this IP address. So you can easily change it using either operating system software or using third-party application softwares. You can change that address. But if we talk about another address called MAC address, that is your media access control address. This address, you cannot change it permanently. This is always found in the network interface card of your machine. This NIC is basically a physical hardware component which is responsible for transmitting your data or receiving your data in a network. If you have NIC in your machine, then only you can perform network communications. If you don't have NIC, you cannot do that communication. This NIC is the main physical hardware component on your system, which is responsible for transferring your informations from your machine, like in terms of transmission mediums, and receiving your informations from other machines in your NIC card. NIC card is mandatory. Without NIC, you cannot perform network communications. So this MAC address is always a permanent address. We call it the hardware address of machine, whereas IP address is called software address of a machine. Okay. The software address, you can always change it at any given point of time. That is why we call it logical address. And MAC address, you cannot change it permanently because it is directly available in the hardware. If you want to change MAC address, means you have to change your NIC. Then only you can change your MAC address. So when we talk about IP versions, we have two versions. One is called version 4, one is called version 6. This version 6, it was basically developed in the year 1998 by this organization called IETF. This IETF full form is Internet Engineering Task Force. Engineering Task Force. This organization has developed this IPv6 in the year 1998. Now, why they have developed this IPv6? When we are still using IPv4 addresses, why there is a requirement to develop IP version 6 addresses? So the answer is very simple. That is, IPv4 address always, it's a finite number of addresses. It is not having unlimited number of addresses. If we look into the size of internet these days, it's a huge network. We're calling it global area network. Means globally, you are accessing informations regardless of whichever country, regardless of whichever state, regardless of whichever city, you are simply just making communications to all the machines on internet. So when we are talking about the size of internet, we don't have any clear idea about how many number of machines exactly are available on internet. How many networks are there on internet? No one can specifically say that internet is equal to this many number of machines, internet is equal to this many number of networks. No one can specifically define that. Why? Because day by day, the size of internet is increasing. Day by day, new devices are getting added on internet. Day by day, new networks are getting created and it is getting connected to internet. That is why exactly the size of internet, it is constantly increasing. So when we are having this type of like huge network where we have these billions of devices are getting connected, and every single machine requires an IPv4 address to communicate, obviously there is a high probability that one day this IPv4 address, it will end. It will be finished. And when there is no more IPv4 addresses left for our machines to communicate, then what exactly we can do? How we can access internet? This is why IETF has developed this IPv6. So that even after the IPv4 addresses are not available, still maintain communications on internet using this version 6 addresses. So majority of the machines on internet are using IPv4 addresses. That is why we are having this conversation right now of IPv4 addressing. It's a 32-bit address containing 4 octets, where 1 octet is equal to 8 bits. So that is your 4 octet into 8. That is how the overall length 32-bit address is coming. We're using dot to separate 1 octet from another octet. Always it is represented in decimal format. And this is an example of IPv4 address. That is the first octet, that is the second octet, that is the third octet, and this is the fourth octet. So since we are using dot in order to separate these 4 octets, and we are writing it in decimal format. That is why these IPv4 addresses, these are called as dotted decimal address as well. Dotted decimal means you are using dot
Recording in
your
Recording.
progress.
internet service provider, right?
Yes, sir.
Who are basically giving you internet connectivity. So always when we as a customer, we need a public IP to use on our machine. This is your ISP from whom we can purchase these public IPs. Okay. Now there is an organization called IANA. Okay. This organization is mainly responsible for assigning numbers to these ISPs. Okay. These ISPs, they purchase these IP addresses from this organization. It's called Internet Assigned Numbers Authority. This organization is mainly responsible for allocating IP addresses to different internet service providers. So these companies, they purchase it from this organization, and we purchase it from these ISPs. Okay. Private IPv4 address is a free of cost address. Means you don't have to pay any charges for using a private IP on your machine. So suppose you are creating a private network, and in your private network you want to use an IPv4 address, then the most suitable option what you are having is using a private IP, because in that you don't have to pay any amount to your ISP for communication purpose. So private IP always is used in a private network, whereas public IP is always used on public networks such as internet. Private IP is not allowed on internet. Why it is not allowed? Because number one reason is it's free of cost. Since it's a free of cost address, everyone is using it. You are using it in your network, I am using it in my network, others are also using it in their network. So if we are communicating between each other in this situation, there is high probability that your machine's IP and my machine's IP, it will be same. Okay, because we have limited private IPs which are free of cost. And if there is same IP address used by the sender and used by the receiver, then there is no communication actually. Okay, because we have the duplicacy of IPs, which is always resulting in terms of no communication. Okay, communication will not be there if you use the same IP address just like my machine, okay, in your network, and you want to communicate with my machine, it is not possible because both senders and receivers IP is same. So this is why exactly it is not allowed, because on internet you are having so many number of machines, any machine can use, okay, the same IP address what your machine is using. So that is why it's not allowed on internet. Public IP is always allowed. Okay, means anywhere on internet, any machine you can access it using a public IP. This public IP, what your machine is using, it is not given to any other machine all across internet. Means no other machine can use the the public IP what your machine is using. So it is simply a unique IP which your machine can only use and no other machine can use it. So that is why this is always chargeable. It is a paid address. Public IP B4 has 5 classes, private IP B4 has 3 classes, and these are your classes. We have 3 classes of private class A, B, C, and 5 classes of public class A, B, C, D, E. Every single of these classes, they have certain ranges. So that is your private class A range 10.0.0.0 to 10.255.255.255. Class B range 170 to 16.0.0 to 172.31.255.255. And class C 190 to 168.0.0 to 190 to 168.255.255. These are all for private range. This is your starting range. This is your ending range. Similarly, for public also, we have the short range. This is what we call the short range. And this range, what you are seeing here, this is called the full range. Full range. So from the interview perspective, we need to remember both the short range and full range of these public classes. Because in interviews, they can ask you any IP address from this full range, or they can ask you the short range of it. Okay, but make sure that you are comfortable giving answers either from the full range or the short range when questions are being asked in the interviews. So 1 to 126, that is your class A range. 127 is reserved for loopback, which we use for self-diagnostic purpose. Self-diagnostics, what is it? We will discuss about it in a moment, but this is your full loopback address range. That is your 127.0.0.0 to 127.255.255.255. This entire range is reserved for self-diagnostics purpose. So 1 to 126 means this is your full range starting from 1.0.0.0 to 9.255.255.255, then 11.0.0.0 to 126.255.255.255. And after that, the loopback address comes, that is 127.0.0.0 to 127.255.255.255. Then class B starts from 120 to 191. So this is your full range 120.0.0.0 to 172.15.255.255. Then 172.32.0.0 to 191.255.255.255. Then our class C range starts from 192, that is 192.0.0.0 to 192.167.255.255, then 192.169.0.0 to 223.255.255.255. Then class D range starts from 224.0.0.0 to 239.255.255.255. Class E range starts from 240.0.0.0 to 255.255.254. Now, why this 254? Because 255 is broadcast. IPv4 global broadcast address is 255. Now, what is broadcast? Broadcast means one to all communication. Okay, one to all communication. Let's say that this is a network. Okay, it's a network where we have a machine called PC1 trying to communicate with all the machines in this network. Okay, maybe this PC1 wants to send a message to all these machines here. So that is here PC2, PC3, PC4, PC4. So to all these machines, it is trying to send a message. So this is one machine communicating to all the machines in the network. So this is your one-to-all communication, always done using broadcast. Whenever you want to communicate from your machine to all the machines in the network, always you use this broadcast address here to communicate. That is your broadcast communication purpose is all 255 is reserved. Then you are having this class D, which is used in multicasting. What is multicasting? That is one to all or one to group or many communication. Okay, so what is one-to-group or one-to-many communication? For example, let's say that this is our network here, where we have our PC communicating to certain group of machines here. Okay, so let's say that this PC1 wants to send a message to only these two systems, not to PC4. So this is one machine communicating to a group of machines. This type of communication is called multicast. Okay. So where you are not communicating with all the machines in the network, you are communicating to a certain group of machines. So this is type of communication is always referred as multicast. Class E is reserved for experiment research. Those organizations like ISRO, DRDO, these are all research and development organizations. When they perform new uh, research on technologies, they perform some modifications on any existing technologies. This is when exactly they use this type of class E addresses for research purpose. Okay, so organizations who are into this research and development business, always for these organizations, these addresses are reserved. That is class E. And class ABC, it is reserved for unicast. As you can see that unicast is there. And what is unicast? Unicast means one-to-one communication. That is a direct communication, what you are doing between two machines directly. Like PC1 communicating directly with PC2. So that is one machine communicating with another machine. This is what we call unicast. Okay. So for that purpose, this particular class ABC addresses are reserved. Okay. So what is actually self-diagnostics? Self-diagnostics involves performing NIC check. NIC means your network interface card or controller, which is always needed for network communication. If your network interface card is actually working, okay, if it is working, then only you can communicate with another machine. You can transmit data, you can receive data. So if this card or controller it's not working, then you cannot communicate. Okay. So it is always required. It is always required that your NIC it is in working condition. So this NIC, where exactly you can find it? On your motherboard. Okay, in your laptop, desktop, motherboard, you can find it. On your smartphone, also you can find this NIC. Okay, it is available in terms of your Wi-Fi adapter. It is available. But this is a hardware component. First of all, it is a hardware component which is always needs to be available in your machine to transmit or receive data, because it is having this NIC is having two channels. Two channels are there. Okay. What are those two channels? One is called TX and one is called RX. Okay. TX channel is used for transmitting your data and RX channel is used for receiving your data. If your both channels are working, it means your NIC hardware is working fine and you can successfully communicate. So how do we get to know that whether our NIC is actually working or not? How do you get to know about it? This is what we do it using this loopback address range. Okay, that is what we call self-diagnostics, because we perform this diagnostics on our system NIC and we verify that whether it is in working condition or not. So we can do this over here from the command prompt. So you can find the command prompt application under Windows system folder. This is your command prompt application. Open it. Or otherwise, you can simply just search here CMD. From there also, you can open this. So from here, you type this command called ping. Then you give the address 127.0.0.1. Now this address, what you are giving here, this address is called default loopback address. Okay. Default loopback address. Now, why we call it default loopback address? Because this is by default, we use it maximum time to perform self-diagnostics. Means to verify that whether our NIC is actually working or not, maximum time we use this address. So this address is called default loopback address for Windows operating system and Linux. Okay. In Linux also we call it. So if we do the ping test, okay, so this is our ping command, and if you press enter, you can see that you are getting the reply. These are all replies. In the ping statistics, you can see that you are sending how many packets? How many packets are sent? 4. How many packets are received? 4. How many packets are lost? 0. And what is the percentage of loss? 0. So 0% loss means what? We are getting 100% success. Okay. So when you do the ping test in your machine with this loopback address, always you should see this type of output. Okay. It means what? Your NIC is working. So how can I say my NIC is working? First of all, NIC is having two channels. One is your TX channel and one is your RX. So TX channel is working or not, we can verify it from the sent. In the sent, we can see that it is a non-zero value here. It indicates that my NIC successfully has transmitted data. And RX channel here, that is the received. Here also we can see that it has received the data. So when you are seeing non-zero values in sent and received, it means your NIC is perfectly working. It's not having any problem. But if you get this type of message called general transmit failure, this type of message is coming when you are doing the ping test. Instead of the reply, you are getting this message. It simply means that you are having two situations in which you get this message. Okay, first situation is NIC is not enabled. It is not and NIC is on, but still message is displayed. It means that your NIC is faulty. Okay, means at the very hardware level, you have some problem. Okay, means your NIC hardware, it is having some issue itself. Maybe some pin is broken, or maybe C is connected in the motherboard. Maybe that slot is having some problem. So these are basically like hardware level issues, what you can always face if your NIC is on, but still you are getting this message. Okay. So uh, if it is not on, okay, then what you need to do is you have to switch on your NIC. And how do you switch on the NIC? That is, you simply just go to the control panel, and you go to your network and internet. Over here, you can see view network status and tasks. Here you can say change adapter settings. And from here, you can right click and you can switch off. So whatever password you have for the admin, you have to give it. You can see that it is disabled. And right now you can enable it. So you can see that it is now enabled. So your NIC is right now on. Okay. But after switching on your NIC, if you're still getting this type of message, okay, it means that your hardware is having some issues. This is one you need to change it. Okay. So This is what you are getting, everyone. If you get your replies like this, it means your NIC is perfectly working. If you are getting this message, it means that you have some like what issues. So either you check your NIC, which is either on or off. If it is off, then switch on, then do the ping test like this, it will work. But if you're still getting this type of message after switching on your NIC, it simply means that you have a hardware problem in your network interface card. At the time, you will have to change it. So always it is not the case that you should use this address only to perform the self-diagnostics. Okay, you can always use any value in between 0 to 255 in the second, third, and fourth octet to perform this self-diagnostics. Okay, for example, ping 127.0.0.10. You can use that. Okay, you will see that you will get a reply. So in the fourth octet, you can see that I'm using 10 here. That is in between 0 to 255, I'm using a value. Okay, but make sure that the first octet, it is always 127 because that is the identifier of loopback. That is how your system identifies that what type of address exactly you are using to perform the self-diagnostics here. Okay, I can also use 127.95.72.46. Okay, so you can see that 95, 72, and 46, it is coming in between 0 to 255. So I can use it, and I can also perform the self-diagnostics. So use the ping command, and you can see that you are getting the reply. Okay, send 4, received 4. So that is how exactly you can perform your self-diagnostics. Okay. So these addresses are very important, everyone. These ranges are very important. So make sure that you remember these address ranges. Like what? No matter whenever you are using any IP address, you should be immediately figuring out which class IP, which type of IP you are using, whether it's public, whether it's private, for what purpose you are using that IP, like unicast purpose, multicast purpose, broadcast purpose. You should be able to, means you should be able to instantly figure out all these things, okay, by looking at the IP address itself. So that is why it is important to memorize all these address ranges, okay, very clearly. So take the screenshot of all this, everyone. Taken.
Yes.
Yes.
Then take the next one. Saurav, you have to take the screenshot. Okay. I'm having some problem in the attachment, file attachment. It's not working properly. You will have to take the screenshot.
Taken, sir.
Taken, right? Then we have the public and private. Here the ranges are coming. Take it.
Done.
Taken.
And here comes some definitions of broadcast, multicast, unicast, and some examples to illustrate what is unicast, what is multicast or broadcast. For example, if we are having a network of 100 PCs, and if one PC wants to communicate to all the remaining 99 PCs in this 100 PCs network, then what type of communication it will be?
The multicast.
Broadcast.
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 100
Class,
PCs, right? One PC to remaining PCs, right? Broadcast. Your PC to my PC. What type of communication is this?
Unicast.
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 And your PC to 10 PCs in one group is what?
Multicast.
Multicast. Okay, remember this.
Sir, class
Now,
A,
tell me,
class A screenshot I want to take also.
class A, this one,
Yeah, sir. One second. Sir.
take it. taken?
Yeah, taken, sir.
All right. So now we are moving on to the subnet mask concept. Okay, so subnet mask means what? You have your IP address where you have this network part and host part, which is there in this IP address of 32-bit. So every single IP address contains these two sections. One is the network section, which identifies the machine's network. So this PC0, this laptop 0, it belongs to which network? That is local area network 1. This laptop 1, this PC1 belongs to which network? This is local area network 2. That is the network part in IP address used to identify the device's network itself. And host part in IP address is used to identify every single device uniquely in this network. Okay, so this is PC1, which is unique in this LAN 2. This is laptop 1. This is unique. So there is no other machine called laptop 1 in this network. It is unique. So all these host machines in this network are identified using host part, and the network of all these machines are identified using network part. Okay, so very simple concept you are having here. How to identify these two things? That is when subnet mask is used. Okay, subnet mask we're having for our default classes. We don't have subnet mask for class D or class E because class D is reserved for what purpose? Multicast. And class E is reserved for what
Research
purpose?
purposes.
Experiment and research. Okay, so we don't have any subnet mask for these two classes. Okay. So what subnet mask we are having available? That is unicast. Okay. So which classes are unicast classes? That is your class A, class B, and C, right? These are your unicast classes. We also call these class ABC IPs as unicast IP as well. Okay, we call it unicast IPs because we use it for one-to-one communication, direct communication. So this is your class ABC subnet mask, what you were seeing. That is 255.0.0.0, then 255.255.0.0, then class C 255.255.255.0. So all this subnet mask, it is given here in terms of decimal format, and that is also in 32-bit address. But we need to convert this subnet mask in binary to actually find that this is this network and host part in our IP address. So what we are doing here is we are converting this 255 in binary octet, because remember our IP address, it is in octet. Octet means what? 8 bits. Okay, that is your octet. So when you are converting your subnet mask, you need to convert it in octet. So that is your 8 ones. You are getting from 255, and this is your 0. If you convert it, you are getting 8 zeros. So in subnet mask, 1 means what? Network bit, and 0 means what? Host bit. Okay. If you see your subnet mask, which is converted over here, so that is your 255 converted. Then this is your 0 converted. This 0 is converted here, and this is your last 0 converted here. Total, how many bits you are seeing?
So 32.
32 bits, right? Yes. Out of 32 bits, how many zeros you are seeing total?
16.
We have 8, we have
24,
8, and we
24.
have 8, right? So that is your 24 zeros. So 24 zeros in subnet mask means what? Host bit, right?
Host.
And how many bits you are seeing network?
8.
8. So 8 ones means what? Network bit.
Network bit.
1 means what? Always network, and 0 means always host. So in class A, we have how many bits network? 8 bits network. And how many bits host? 24 bits host. Okay, so that is your host, host, and host. 8, 8, 8. That is 24. And this one is 8. This is your network. Similarly, in class B, you are having what? 255. This 255. So how many ones? 16. So 16 ones means what? 16 are your network bits in class B. And how many zeros we are having? This is your 8 zeros. This is your 8 zeros. So total 16. So that is your 16 host bits. And in class C, we have 255, 255, and 255. Total how many network bits?
24.
24. So that is your network bits. And how many bits are 0?
8.
8.
8.
Right.
Are
So
the
that
host
is
bit.
your 8 host bits. Okay. So 1 always represents network bits and 0 always represents host bits in subnet mask. So let's understand how to calculate this network and host bits using some examples. So here we are having example 192.168.100.1. So in this IP address, focus on the first value. First value is what? 192.
192.
Now tell me that this value 192 belongs to which class of IP? Which class?
Class C.
It is a class C. It is a class C. Like what? Not because here it is written. Tell me the reason why it is class C.
So because there
Why
are
it is a
24,
class C address?
24 network bits.
No.
So 24 ones
Why
in
it is
a
a
subnet.
class C? No. Subnet mask things are coming like what afterwards. First of all, we are defining the class of IP by seeing this first value. You are saying that it is a class C IP, right?
Yes, sir.
Class C IP. Why do you say that it is a class C IP? Very simple. Class C range starts from what?
Yes, sir.
192, right?
192.
Yes. That is why it is a class C IP. The
Yes, sir.
range. You have to remember the range. So what is the class C subnet mask of it? Network, and network, right? So that is
And
your
host.
8 ones, 8 ones, and 8 ones, 24 ones, right? And this is your last octet, which is what? Host.
Host.
So it means that in our IP address, 192.168 and 100 will be what?
Network
Network.
bit.
And this one will be what? Host. Yes. Similarly, second example, 150.10.0.1. Focus on the first value, 150. Which class?
Class B.
Class B.
Why it is class B?
So from
Because we
ranges.
define in the range.
Defining range means 120 to 191. This 150 is coming, right?
Yes, sir. 128 to 191.
Yes. That is why it is a class B. So we need to apply the class B subnet mask, which says that we have 2 octets which are network octets, and we have 2 octets which are basically host. Right. So it means that in our IP address, 150.10 will be what? Network. And 0.1 will be what? Host. And similarly, in our third example, 20.90.0.1, focus on the first value, 20. Which class?
Class A.
Class A.
Why it is class A?
So
It is
because
defined
ranges
in
is
class A
class A
range.
from 1 to 126.
Because it is coming in this 1 to 126 range. So what is the class A subnet mask? We have 1 octet network and 3 octet is what? Host.
Host.
Right. So it means that 20 will be what? Network. 90, 0 and 1 will be host. Understood the process?
Yes, sir.
Everyone got it? Any confusion?
Sir,
Okay.
how will I define the host and network?
How do you define the network and host? That is using subnet mask, right? When you are saying 255, 255, 255, that is defining network bits. Okay. And when you are saying 0, it is defining what? Host bits. So whatever octet you are seeing, 255 in the IP address, it will be what? Network. And whatever like what octet
Zero.
you are seeing 0 in subnet mask, that octet in IP address will be what? Host. Okay. That is how exactly you define it. All right. Now take the screenshot of this. Taken.
Yes, sir.
Take this next part. Done.
Yes, sir.
Yes, sir.
Yes,
All
taken.
right. So now we are moving on to the next concept. That is your advanced networking concept called CIDR. Okay. Now CIDR stands for what? Classless interdomain routing. Okay. Now what exactly it does? That is, it is using some notation here that is called slash notation. Okay. To represent the number of network bits in IP address. Okay. Means this is your slash, and whatever value you write here after the slash, that is representing number of what type of bits? N bits. N bits means network bits in IP. Okay, in IP address. So as you can see that these are the same three examples, right? What we have taken in subnet mask, the same three examples you are seeing it, correct? But can you tell me the similarity of these three examples and these three examples here? What is the similarity? IP address is same, and yes, IP address is same, right?
Sir, network
Says
bit.
Right.
number of network bit is same, right? Yes or no?
Yes, yes.
If you see very carefully, that is your class C address, right? That is your
Yes.
255, 255, 255
NNN.
means 8 plus 8 plus 8. That is your what? Network
24.
bits, right?
Yes.
Similarly, this one is what? 150. So that
16
is
network bits.
255, 255. That is 8 plus 8, 16. And this is your 8. So that is your slash 8. What
So
you
we
were,
only write network bits after
yes,
slash.
always when you are using CIDR, you have to write the number of network bits. You don't have to mention host bits. If you see the subnet mask here, we have to represent network and we have to represent host bits here. But in CIDR always represents, okay, you
Network bits.
use slash notation to represent network bits because host bits automatically is calculated based on this formula. Okay.
Yes, sir.
So what exactly you are doing here, that is 32-bit address, that is your IPv4 address, total length. When you are giving slash 24 here, slash 24 is subtracted from 32. That is how, example, if I'm talking about slash 16, so 32 minus 16 is how many? 16. So that is your 16 host bits, right? In class B. Similarly, slash 8. Slash 8 means what? 32 minus 8 is how much?
24.
24. So this formula always is performed, okay, by machines to calculate host bits. So every single machine knows all these IP addresses. They know the ranges of class A, B, C, all these ranges. They know the default subnet mask. They know the default CIDR. Okay, just like your default subnet mask here, you are having default CIDR. Also for class A, it is what? Slash 8. Class B is what? Slash 16. Class C is what? Slash 24. Okay. And when you are simply just giving this number of network bits with the slash, your machines like your laptop, desktop, all these machines, they calculate the number of host bits using this formula. Okay. So this is the advanced way to represent your number of network and host bits in IP address, where you don't have to mention the network and host bits, just like subnet mask here. You simply mention the number of network bits. Your system automatically figures out host bits using this formula. Understood?
Yes, sir.
Take the screenshot of it.
Taken, sir.
Taken?
Yes, sir.
Yes, sir. Taken.
All right. Now we are going to be looking after the decimal to binary conversion here. Okay. So I hope that you guys know the decimal to binary or binary to decimal conversion, right? All of you? powers of 2 we are going to be using. 2 raised to 0 is how much? 1. 2 raised to 1. 2 raised to 2. 3.
8,
2 raised to 4. 2 raised to 5.
32.
32. Then
2
2
raised
raised
to
to
7.
6.
64,
64. 7.
128.
128. Then 2 raised to 8.
256.
256. 2 raised to 9.
512.
512. 2 raised to 10.
1024.
1024. Then 2 raised to 11.
2048.
48. 2 raised to 12.
4096.
4096. 2 raised to 13.
8192.
8192. 2 raised to 14.
1638.
16384. 2 raised to 15. 32768. 2 raised to 16. 65536. And 2 raised to 24. This is what you need to remember. 16777 216. Okay. This particular powers of 2 you need to remember. Okay, for decimal to binary conversion and for upcoming sessions also we need this table. Okay, take the screenshot of it.
Taken, sir.
Taken.
Sir, no, sir. 1 second.
Everyone taken, right?
1 second, sir.
Taken, right? All right. So now we are going to look into the octet. Okay, because our subnet mask, IP address, everything is in octet. Octet, we are having how many bits? 8 bits, right? And if I'm talking about a bit, what is a bit? 0 or 1, right? That is your bit. So minimum value in an octet, minimum value in an
1.
octet is always 0. Okay, decimal is 0. And maximum value in an octet value
1.
that is always
1.
255. Okay, 255. So 0 is the minimum, 255 is the maximum. Means total how many values we have in between 0 to 255? 256. Total 256 values, right? Yes or no?
Yes.
Yes, sir.
Starting from 0 to 255, we're having total 256 values, right? Now, since the minimum value is 0, we're writing 8 zeros here. First of all, write 1, 2, 3, 4, 5, 5, 6, 7, and 8. So that is your 8 zeros. And all these 8 zeros, we are writing the powers of it. So that is 1, 2,
4,
4, 8, 16, 32, 64, and
128.
128. All these powers are coming from
To the
powers
power
of 2,
1,
right?
0 to
So
1.
2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and 2 raised to 7, right? Now let's convert n power. Okay, let's say we're talking about a number called 165. Okay, we need to convert this number. So very simple and easy process. What you need to do is see the number here and find which value is lower than this 165 here. Which value is
To
lower
the
than
power 7.
165? 128, right? This is 128. So let's take this value. So convert it into 1. Okay. Whichever value you are taking, just convert it into 1. So 128, then 64. If we add 64, then it becomes what? More than
More than
165.
65.
So it means we can take 32.
Sir.
So 120 plus 32, it means what? 160.
160.
So let's take this, convert it into 1. And we need how many more? 4.
5
Right. So 160 plus 4 is 164 here.
and plus 1
Plus we need 1. So we are taking which power? 4
to the power 2 and to the power 0.
and 1. So it means, what is the overall result?
Remaining are
0,
0.
0,
That is
0,
1, 0,
0.
1, double
0,
0,
0,
and
1,
1,
0, 1.
0, 1. That is your 165. Okay.
Yes, sir.
Let's take another example. So let's take another example, say 200 here. So 200 means we're taking which power first? 2 raised to 7, 128. So convert it. Then we are taking which power?
64.
2 raised to 6. So 120 plus 64 is how much? 192.
Yes, sir.
So let's take this one, and plus we need how many?
To the power 3.
8. That's it. So that is our result, which is 1 1 0 0, then 1, then 0 0 0.
0.
Right. That is your overall result. Now, if we are converting our maximum value into in an octet, so what is the maximum value of an octet? 255. So let's convert this number here, 255. So first of all, we're taking 128.
All ones.
So that is 1. Then we're taking 64. So just keep on adding 192 plus 32.
Plus 16.
Plus 16.
So that is your 224, right?
Yes, sir.
Plus 16. That is
Plus
your
8.
240. Plus 8.
248.
So that is your 248.
Plus 4.
Plus 4.
Plus 4.
252.
That is your 252. Plus
Plus
2.
2.
254.
So that is your 254
Plus
plus
1.
1. So that is your 8 ones, right?
All
1,
ones.
2, 3, 4, 5, 6, 7, 8. That is how you are getting your 8 ones. Understood this conversion process? Everyone got
Yes,
it?
sir. Yes, sir.
Okay. Now let's convert a binary into decimal. Let's say we're talking about 1 0 1 0 1 1 0 0. Convert this in binary, in decimal. So very simple process. Write the power, that is 1 2 4 8 16 32 64 and 128. And whatever ones we are seeing, we're just adding it. So 128 plus 32 is how much? 160 plus 8, that is your 168 plus 4, that becomes what?
172.
172. That is your result. Getting it?
Yes.
Just write the values of these bits over here. Okay, so these are your bit position values. So this bit position value is what? 1. This bit position value is 2. Just remember this. It will help you to perform this conversion very quickly. So when we talk about subnet mask, okay, subnet mask. In our subnet mask octet, if we are having one network bit and 7 zeros, okay, then what is the value of this octet? This entire octet value will be what?
So 255.
128. Because this value is what? 1, right?
247.
Yes. So the entire octet value will be what? 128, right? So if you have one network bit, that is 1 means what? Network bit in subnet mask, right? So if you have one network bit, then the value of the octet will be 128. If you have 2 ones and 6 zeros,
20
then
plus
what will be the
60.
value?
192.
192. If you have 3 ones and 5 zeros, then
192 plus
224, right? 224. If you have 4 ones and 4 zeros, then to
Double
40.
three.
Okay, to 40.
40.
If you're having 5 ones, 1, 2, 3, 4, 5, and 3 zeros,
248.
248.
So
If you
this
have
is
6 ones, 1, 2, 3, 4, 5, 6, and 2 zeros, then
252.
252. If you have 7 ones, 1, 2, 3, 4, 5, 6, 7, and 1 zero,
Recording in progress.
255.248.0.0,
0.0.
right? So if we see, that is the same result, right? Yes or no?
Yes.
That is the same result. You can see
Yes, sir.
255.248.0.0. Here you can see 8 ones. Here you can see 5 ones. The remainings are 0. For example, if I'm talking about slash 27. Okay, so slash 27, let's do the conversion here. Slash 27 means what? 27 are network bits, right? So 1, 2, 3, 4, 5, 6, 7, 8. That is your first octet. Then 9, 10, 11, 12, 13, 14, 15, 16. That is your second.
Okay.
Then third
One,
is 1, 2, 3, 4, 5, 6,
5,
7,
6,
8.
7.
That is your third octet.
That I got
24.
And we need
3 1.
3 ones. And remaining 5 will
0.
be zeros. That is your fourth.
4 packet.
So it means 8 ones we have 255, 255, 255 dot 3 ones means 224. That's it. Can you see the same result?
Yes, sir.
Right. This is how you perform the conversion. Understood the process?
Yes.
All right. Take the screenshot of it. Because I'm going to ask you some questions from here in a moment. Tell me if you have any doubts in this conversion process.
Please, sir, remind this that how the 13 is converted in this form.
How this 13
Converted
is
in
converted.
this. Yes, sir.
Okay, very simple process. Okay, 13 means what? 13 means you need 13 network bits, right? N
Yes, sir.
bits. Okay, so 13 network bits means you need to write 13 once. So 1, 2, 3, 4, 5, 6, 7, 8, right? Then 9, 10, 11, 12, 13, right?
30. Yes, sir.
13. So that is your second octet, right? It is a second octet. This is your first octet, correct?
Yes, sir.
Octet means we have 8 bits. So in the second octet, in 8 bits, you have 5 ones, means what? 3 bits will be zeros. Yes or no?
Yes. Yes, sir.
Yes. So if you calculate here, then this 5 bits, it means what? 128 plus
78.
64 plus 32 plus 16 plus 8. That is your 5 bits values, right?
Yes, sir.
If you add them together, you are getting what? 248.
28.
Yes. So this first octet value is what? 255.
55.
Second octet value is what? 248.
28.
And third will be what? 0 and fourth will be 0.
Yes, sir.
That's it.
Yes, sir.
Okay. Everyone has taken the screenshot?
Yes, sir.
All right.
Second.
So this is what uh, this is your range. Okay, this is your IP address full range or public. I need all of you to memorize these ranges, specifically the short range and the full range of public classes. I will ask you some questions from here. Okay, in a moment. This up to here. Okay, private address range, it is easy. You can do it without any problem. But public address ranges, because you have short range and full range is coming, I need you to memorize this public all classes range. Okay, for what reason class A addresses are used, what is unicast, what is multicast, which one is used for broadcast, everything. Okay, and this particular conversion, if I ask you any values from here, you should be able to tell me the subnet mask of it. If I ask you subnet mask, you should tell me the CIDR of it. Okay, because maximum time these questions are asked. Okay, they can ask you CIDR, they will tell you what is the subnet mask of it, or they will simply just give you a subnet mask and they will tell you what's CIDR value you have. So this particular table and this public address range, this is what you need to prepare right now. Okay, time I'm giving you 15 minutes for all of you to complete it fast. Okay, the CIDR to subnet mask conversion, it is totally formula based. It totally depends on your values calculation. Okay, so you can calculate it and you can tell me the values, but this range is very important. So make sure that you tell me the full range. Full range means this. Okay,
Sir,
this is your
I
full
had
range.
joined,
Tell me.
I had joined late, sir, after 9:30 o'clock. So
Okay,
within 15 minutes, sir, please explain me that afterward, whatever you had explained today, sir.
these are your IP address we have explained. This is your IP address. Okay, IP address, the differences between public private classes, then the ranges. These are basics only. Okay, what we have discussed. We did not discuss any advanced things here. So the things what you already have learned in your basics of networking, those things only. But here
Yes,
I
sir.
have mentioned the full range here. The full range you need to
I didn't
memorize
get your voice, sir.
for all these classes. Yes, can you hear me properly? Can you hear me properly? All right, looks like a network issue. Just hold on. All right, can you hear me properly now?
Yes, sir. We can hear.
Okay, so these are your full ranges. You have to memorize these full ranges. Okay, that is your full range. From the interview perspective, it is important that you remember the short range and the full range both. Okay, so prepare it. I will ask some questions from these ranges and these conversions in 15 minutes.
सर
बोलो
सर क्वेश्चन समझ में नहीं आया।
कौन सा कैलकुलेशंस?
नहीं, जैसे कि वो कि हमको 15 मिनट में क्या प्रिपेयर करना है।
ये तुम्हारे जो पब्लिक रेंजेस हैं, ये सारे रेंजेस तुम्हें प्रिपेयर करना है। शॉर्ट रेंज क्या है, लॉन्ग रेंजेस क्या है?
ये रेंजेज हमको प्रिपेयर करना है, ये आप मतलब हम लोग से पूछिएगा वन बाय वन।
करेक्ट करेक्ट, रैंडमली पूछेंगे। ओके, ऐसा नहीं है कि सीरियली पूछेंगे, रैंडमली 10 to 15 पार्टिसिपेंट्स को पूछेंगे।
ओके
ठीक है, तो
ठीक
ये
है।
रेंजेस को इधर ही मेमोराइज कर लो। कॉन्वर्ट जो है, इसका कन्वर्शन क्या है, सबनेट मास्क क्या है, ये सबनेट मास्क का सीआईडीआर क्या है, ये भी प्रिपेयर करो।
ओके।
All right, finished. Everyone completed?
Yes, sir.
Abhinav,
Yes, sir.
yes, go on. Tell me the public range.
Public
The range of public classes.
public classes, class A, class B, class C, class D, and class E. The range for class A 1 to 126. For class B 128 to 191. For class C 192 to 223. For class D 224 to 239. And for class E 240 to 255.
Tell me the full range, full range.
Full range for class A 1.0.0 to 9.255.255. And second is 11.0.0.0 to 126 dot 255.255.255. For class B 128 .0.0.0 to 172 dot 15 dot 255.255. And second is 172.32.0.0 to 191 dot 255.255.255. For class C 192.0.0.0 to 192 dot 167.255.255. Second is 192 dot 169.0.0 to 223.255 dot 255.255. For class D 224.0.0.0 to 239.255.255.255. And for class E 240.0.0.0 to 255.255.255.254.
And cluster address. What is the broadcast address?
Broadcast address is 255.255.255.255.
Correct. All right, Aditya is here.
Yes, sir.
Go on. Public range.
Sir, for class A, in the local range is 1 to 126, and the broadcasting range is 1.0.0 to 9.255.255.255. And for class
Okay.
D, the local range is 128 to 191.
Now,
And
after that, you are having 11.0.0.0, right?
Yes, sir.
That range you have to tell full.
For class A, 1 to local range 1 to 126, and broadcasting range is 1.0.0.0 to 9.255.255.255, and 11.0.0 to 126.255.255.255. For class B, the local range is 128 to 191, and the broadcasting range is 128.0.0.0 to 172.15.255.255, 172.32.0.0 to 191.255.255.255. And class C, the local range is 192 to 223, and the broadcasting range is 192.0.0.0 to 192.167.255.255, 192.169.0.0 to 223.255.255.255. For class D, the local range is 224 to 239, and the broadcasting range is 224.0.0.0 to 239.255.255.255. The last one is for class C. The local range is 240 to 255, and the broadcasting range is 240.0.0.0 to 255.255.255.254.
All right.
Yes, sir.
Next, Bhagyashri is there. Bhagyashri. Uh, Daya is there. Daya Chore is here. Yes, go on. Public range.
Class A, sir, 1 to 126 under bracket 1.0.0.0 to 9.255.255.255 and 11.0.0 to 126.255.255.255. Class B each 128 to 191 and range 128.0.0.0 to 172.15.255.255. Next class C 192 to 223 is 192.0.0.0 to 192.157.255.255. In class D 224 to 239 is 224.0.0.0 to 239.255.255.255. In the class E 240 to 255. Last one broadcast is 255 to 255 to 255 to 255. That's all, sir.
All right. Next, Dinesh is there. Dinesh. Harsh is there. Harsh.
Yes, sir.
Yes,
For
go
class
on.
A, it's from 1 to 1 to 6. Its full range is 1.0.0.0 to 9.255.255.255. Then 11.0.0, then 1 to 6.255.255.255. Then class B is from 128 to 191. Its full range is 128.0.0 to 172.15.2525. Then 172.32 .0.0, then 191.252525. Then there is class C from 192 to 223. Its full range is 192.0.0.0 to 192.167.2525. So subpart is 192.169.0.0 to 223.2525.255. Then there is class C from 192. Class G from 224 to 239. Its ranges from 224.0.0.0 to 239.252525. Then there is class E for research purpose 240 to 255. Its full range is 240.0.0 dash 25255 till 255 to fourth octet.
All right. Next, Jitendra is there. Jitendra. Kapil.
Yes, sir.
Yes, go on.
First class A IP address 12126 range 1.0.0 1.0.0.0 dash 9.255.255.255.255 11.0.0 slash 126.255.255.255 28 128 dot slash 191 IP address 128.0.0.0 and 272.15.255.255 and 272.32.0.0 291.255.255.255 class C class C 192 slash 223 292.0.0.0 267.255.255 and 292
192, right?
192.162.0.0 and 223.255.255.255 class D 224 slash 239 and 224.0.0.0 239.255.255.255 and class E 240 dot slash 255 and range 240.0.0 slash dash 255 dash 255 dash 244. That's
Okay,
all.
memorize it properly. Okay. Next, Jasim is there. Jasim. Asif is there.
Yes, sir.
Yes, gone.
Okay. For class A, range is 1 to 126, and range is 1.0.0.0 to 9.255.255.255, and another is 11.0.0 to 126.255.255.255, and for class B, range is 128 to 191 and 128.0.0.0 to 172.15.255.255 and 172.32.0.0 to 191 dot 255.255.255, and for class C range is 192 to 223, 192.0.0.0 to 192.167 to dot 255.255, and another one is 192.169.0.0 to 200.255.255, and for class D ranges 224 to 239.
Recording in progress.
All right.
C is equal to 192 class. I'm not audible, sir. But
All right, continue. Go on, continue.
class C 192 to 223, 192.0.0.0 to 192.16.
Recording in
It is
progress.
one of the most important concept in your CCNA advanced networking module. Okay. And to understand this subnetting, make sure that what we have discussed today, the subnet mask, the CIDR, the decimal to binary conversion, the powers of the decimal to CIDR, okay, like subnet mask to CIDR or binary conversion, everything, the range of IPs, everything, you revise it properly and attend the next session, because everything you will be getting it in the next session itself. Okay, so that is what we are going to discuss, the subnetting concept in the next session. All right.
Yes,
So
sir.
just hold on, let me take your screenshots. Yes, tell me.
Sir, one question, sir. Public IPv4 address class 1.0.0, and then it comes 9, and then it comes 11. Sir, where is 10? It is reserved for
10 is
something.
coming in private. 10 is coming in private, right? You can see that in between 9 and 11, that is your 10 coming
Okay.
in private, free of cost.
Okay. Now I got the logic. Okay.
All right.
Sir, one question more, sir.
All right. Tell me.
Sir, one confusion in
Yeah,
the
one class.
Hello. Class B, that is
Tell
how
me.
it is how the subnetting is converting in the to 128 to 191 range. How it is comes to 128.0.0 to 172.115.0.
See, the thing here is that is the first octet value. What you are seeing, the starting range, it is the first octet. Okay.
Yes.
So, but IP address is not about first octet, right? It is about 4 octets, correct?
Yes, sir.
So what value you are seeing here, that is the first octet value. Okay. And this is
Yes.
your last octet value. You can see that.
Yes, sir.
Okay. So that is your full address. Full address you are having. That is not the full address. It is giving first octet only. All right.
Yes, sir.
Okay. So I will see you guys in the next
सर
session.
ये
Okay.
कोई फिक्स डिजिट होता है या फिर हम कुछ और
Fixed है, ये fixed है, fixed ranges हैं.
अच्छा और ये हमारा क्लास ए से क्लास बी में जाते हैं सर तो
हाँ वही मतलब ये तुम्हारा
7 कहाँ
फिक्स
गया सर
रेंजेस डिफाइन किए गए हैं, इनको तुम्हें याद रखना है.
नहीं तो
जब भी
इसके
कौन
sir,
सा भी आईपी,
calculation method, I want to know that how it is calculated into this form.
it is not calculated, it is given like this, it is
That
defined.
have to be remembered, sir, I think.
हाँ ये डिफाइन किया गया है इस नाम. ओके, इसी फॉर्मेट को डिफाइन किया गया है कि अगर तुम्हारा क्लास ए 1 से स्टार्ट होता है, मतलब तुम्हारा फर्स्ट ऑक्टेट है 1, उसके बाद 0.0.0 से लेके 9.255 तक ही जाएगा. उसके बाद 10 आ जाता है जो कि प्राइवेट पे है, तो उसके लिए ये 9 और 11 के बीच में तुम्हारा 10 जो है वो मिसिंग है. फिर
Loop
से
back.
11 से स्टार्ट होके फिर जा रहा है 126.255 तक. ओके, ऐसे डिफाइन किया गया है ये सारे रेंजेस. तो जो बेसिकली डिफाइन किए गए हैं उसी पर्टिकुलर क्लासिफिकेशन को हम लोगों को याद रखना है. ठीक है.
Yes.
ऑल राइट. सो
सर
आई विल
इसमें
सी यू
ना
गाइस. हाँ
कल दोबारा
बोल.
सर एक बार डिस्कस करना सर
कौन सा चीज.
नहीं सर ये वाला पहले वाला समझ में आ गया सर क्लास बी में क्या है सर एक मिनट रुक जाओ
क्लास बी में
क्लास बी
क्लास
में
बी
क्या
में
है सर
देखो.
यहाँ पे 172 है सर और दूसरे वाले में भी 172 से ये स्टार्ट है
ये देखो ये सेकंड ऑक्टेट पे फोकस करो. सेकंड ऑक्टेट किधर पे है, 15 है और ये 32 है.
यस
तो एग्जैक्टली 15 और 32 के बीच में 16 से लेके 31 गायब है, राइट? है कि नहीं?
यस यस
16 से लेके 31 इधर पे नहीं है ना, ये
नहीं है
क्योंकि ये प्राइवेट है, ये रेंज प्राइवेट है.
ओके
ओके, तो हम लोगों को दोनों ऑक्टेट को देखना है. ओके, सिर्फ फर्स्ट ऑक्टेट को नहीं देखना है, सेकंड ऑक्टेट को भी देखना है. अगर तुम्हें प्राइवेट एड्रेस डिफाइन मतलब फिगर आउट करना है तो फर्स्ट ऑक्टेट को देखो, सेकंड ऑक्टेट को देखो, इधर भी तुम्हें डिफरेंस निकल आएगा. ठीक है.
यस
ठीक है, जो भी कंफ्यूजन है मुझे नेक्स्ट सेशन पे बता देना. ठीक है, आई विल क्लैरिफाई इट. ठीक है.
ओके
ऑल राइट, सो बाय, टेक केयर एंड गुड नाइट एवरीवन.
Okay, sir.
थैंक यू एंड सेम टू यू
Good night, sir.
यस,
Thank you,
गुड
sir.
नाइट ऑल.